Here we go with Unit 8 redox. So an oxidation, reduction, reaction involves the transfer of electrons. XFR is just short for transfer of electrons. A couple things that we have to memorize. Oil rig, which is oxidation, is losing electrons. Reduction is gaining electrons. Some people, like Leo says, GER, losing electrons oxidation, gaining electrons reduction. I prefer oil rig, but either way is fine. So, oxidation is when something loses electrons. Reduction is gaining electrons. And in a reaction, electrons lost by one species must equal electrons gained by the other species. Redox reactions will be written as oxidation half reaction and a reduction half reaction. So this is a lot easier to teach you an example. So let's do an example here of a redox reaction. 2AgNO3, silver nitrate, plus copper yields CuNO3, 2 copper nitrate plus silver. And if we look at these, right, this is going to be aqueous, dissolved in water. This will be solid. This will now be aqueous, dissolved in water. And this will be solid. So when we're doing redox reactions, first thing we have to do is assign oxidation numbers to everything. Okay? NO3, if we look on table E, it's nitrate, which is NO3 minus 1. The whole thing's minus 1. So that means the silver is going to be plus 1. An element by itself is 0. Nitrate, each one is minus 1, but there's 2 of them. So minus 1 times 2 is minus 2. The whole thing has to be equal to 0. So copper is going to be plus 2. And an element by itself is 0. Some other rules. Right, so table E, we got right off of table E. Metal by, or anything by itself is always 0. Some other rules. Fluorine is always minus 1. Oxygen's always minus 2 unless it's bonded with fluorine. Group 1 is always going to be plus 1. Group 2 is always going to be plus 2. Hydrogen is going to be plus 1 unless it's bonded with a metal. Minus 1 when bonded with metal. Okay, so now we have to look here and see what changes. All right, we can see silver changes from Ag plus 1 to Ag0. So silver plus 1 is going to become silver 0. We can see that Cu0 is going to become Cu plus 2. Now, how do they do that? Well, they do that by gaining or losing electrons. And when we add electrons, we always add the electrons to the more positive side. So since Ag plus 1 is more positive than Ag0, we're going to add an electron here. And it's 1 electron. It's going to balance it out. Cu0 to Cu plus 2, well, we have to add 2 electrons to the more positive side. Okay? And we have to decide which is oxidation, which is reduction. Well, oxidation is losing, reduction is gaining. So since silver +1 here is gaining an electron, this is reduction. That means also that silver +1 is the oxidizing agent. The oxidizing agent is what gets reduced. This other reaction here is oxidation. That means the copper is the reducing agent. All right, so in order to balance these, we have to balance the number of electrons. So since there's 2 electrons lost here, we have to balance this, change this so 2 electrons are gained by multiplying this entire one by 2. And we can see, based on this balanced formula, right, that the 2 in front of the Ag plus 1, that's why there's a 2 in front of the Ag plus 1 here. There's a 2 in front of the Ag0 here, which is why there's a 2 in front of the Ag0 here. A 1 in front of the Cu0, a 1 in front of the Cu0, a 1 in front of the Cu plus 2, so there's a 1 in front of the Cu plus 2. And then this redox equation is balanced. All right, so the next things we looked at in redox were cells, both voltaic and electrolytic. So if you look at a voltaic cell here, up a little. All right, so the first thing we always have to decide when we're looking at a cell is the flow of electrons. And to determine the flow of electrons, we're going to look on table J. So the first thing we do, when looking at a cell, determine the flow of electrons with table J. That's always going to go from the higher element to the lower element. So we look here, we see aluminum, and titanium. So we look here, we find aluminum right here, and titanium. So since aluminum is higher than titanium, electrons flow from aluminum to titanium. Okay, so that means aluminum is becoming Al3 plus. Why 3 plus? Well, because that's what aluminum does, because it's group 13. But also we can see the Al3 plus in solution here. Okay? Plus those 3 electrons it gave up. We can see here, since titanium 1 plus will gain electrons, Ti 1 plus 1 electron becomes Ti. So oxidation is losing. So this is oxidation. Reduction is gaining. So this side is reduction. The other phrase we have to memorize, red cat and an ox. Reduction at the cathode. Okay. The anode is oxidation. So this is our anode, and this is our cathode. Purpose of the salt bridge to allow for movement of ions, to prevent buildup of charge. Purpose of the wire, movement of electrons. The electrons are flowing, we saw, from left to right. Cathode is the titanium. That's the cathode. The anode is the aluminum. Now, since here, titanium 1 plus is going to be joining up. Electrons come flowing in here. Titanium 1 plus is attracted to them to make titanium, so the titanium will gain mass. Right? The cathode always gains mass. The anode, in this case the aluminum, will lose mass. The half reactions we wrote, the oxidation half reaction and the reduction half reaction. Now this is a battery. Other type of cell we learned about was an electrolytic cell. But here we basically do the same thing, except this one is non-spontaneous, so it needs to be connected to a battery. The first thing we do is determine the flow of electrons. And in a battery, the electrons flow out of the negative terminal. So here, the gold is losing electrons and becoming Au3 plus 3 electrons. Here, right, electrons flow into the fork, and Au3 plus, that's floating in solution, bonds with 3 electrons to make gold. And it ends up gold plating the fork. And so this is oxidation. Oxidation is losing. Red cat and ox, so this is the anode. Sorry, A-N-O-D-E. This is reduction. Reduction is gaining. Red cat, this is the cathode. Okay, so the electrode connected to the fork was the cathode. The gold electrode was the anode. It's going to be negatively charged. The fork, the cathode, gains mass, and the anode loses mass. Here's our reduction half reaction. Here's our oxidation half reaction. Right, this is an electrolytic cell. It needs a battery. All right, that brings us to the end of redox. I will see you guys in school.